Y equals A to the BX. They all work off of this format. Take your initial value and lay out all the parts. This is my A, my initial value. I'm going to double. This is my rate. This is my B. Here's every 3 hours. Now, if you do this and you put in your 2,500 and you're going to double, and this is time, this would be every hour. But instead, you want every 3 hours. That gives you a cycle of every 3 hours. Start like this. Start at the 0. So at the 0, you have 2,500. At the 3, double it. So when you make your equation and you look at your table, it should have those values there. If it doesn't, then something went wrong. Maybe you forgot to divide by 3. Maybe you did something wrong. This just had a little plug-in. Just put the pieces in. First, you had to give me a representation during the first 24 hours. So if I want a 24-hour period, I need X to go from 0 to 24. And you're going to see that it's increasing. Don't forget, all your exponential curves come from quadrant 2. Whether it's an increasing or whether it's a decreasing. So when they ask for a complete graph, it does come from quadrant 2. When they ask for a situational graph, situational applies to this application. It can only come from quadrant 1. Because if x-axis is your time, you're not going to have negative time. Okay, so we plug this in. You have to put 6 in here and show me the 6. You could look it in your table and pull out the 6. Or at 6 we would have 10,000. You could have figured it out this way. Plugged it in there, went to your graph. This one, y1, y2. See where they intersect. Even if you found it on your table, you wouldn't get exactly 100,000, and you got to give me 3 decimal places on your answers. So you're going to have to make this one a little bit more exact. Okay. Questions? Could you get them in the calc? Stop me if you have any questions. Say I can't get it in my calculator, can't figure out where to put the time. Everybody's good?
Yep.
Here's a population that's decreasing. Again, we start with this. This makes life very simple. Remember, there's no compounding, ever. There's no compound annually or anything. That's only for interest problems. These are straight problems.
I know you said before, but I didn't understand exactly. Did you say you have to include quadrant 2 when you're drawing?
If they ask for a complete graph like this, then where did this come from? If it only started here, and we saw it start here, it had to come from somewhere else. All your exponential curves go from the second quadrant to the first quadrant, increasing or decreasing. So a complete graph shows me everything. Then easy to do, just cross this out. This is your application. This is your problem situation.
So when it says what portion of the graph represents problem situation, you can just...
Quadrant 1.
Okay, that's all you have to write?
Cross this out, quadrant 1.
Okay.
Because your exponential curves come from quadrant 2. They got to begin somewhere. But because we do an application, we only want quadrant 1. Kind of like your parabolas. You know when you launch the rocket, and I'm standing 300 feet off the ground, and your rocket launches like this and comes back and hits the ground? Where did this come from? It came from quadrant 2. But do we use quadrant 2 when we use this parabola? No. This is my complete graph. This is my application, my situation. Okay, so now we're decreasing. Decreasing is the 1 minus. This is what's retained each year. Each year I'm going to get about 97.625% of the population that was remaining.
I have a question.
Yes.
Sorry. Is it okay if you leave it in the 1 minus 0.02?
Absolutely. I wouldn't, yeah. I put it both ways in case you have it on yours so that everybody can see it.
And then I have a second question. For the determine when the population count will be, if I just write the point at where they intersect and then say,
If you write the point where they intersect, you're going to give me this as your answer.
No, like if I did that to show like I got that from my graph and then wrote like 37.45 years.
Yeah, I gotta get this answer. This is fine. I need to see your work.
Yeah, like,
But
wait.
some kids just leave me this. That's not an answer.
No, if I just wrote that and say like intersect at.
And you did this? Is that what you're asking me? No. Okay. I'm missing this much rest.
So like if I just wrote like the intersect at and then the point.
That's perfect.
And then that's fine.
That's perfect.
Alright, I just want to make sure.
As long as your final answer gives me this. Don't give this as your final answer.
No.
Yeah.
I just wanted to make sure you didn't want it to
That's
go
where I
like
want to
that.
see the work. Nope, this is perfect. Perfect.
Thank you.
We're perfect. Any other questions? We're good? All right,
Just
stay
wanted to
with
make
this.
sure that was
Yeah, absolutely. And I like the fact that you asked that because some of the hardest time is showing the work on the graphs.
Yeah.
Because everybody puts it in their calculator. Are you all listening where Ash is coming from?
Yeah.
When you have a task on this, you have to show me work. You can't just put it in your calculator and assume I get that you put it in your calculator. You gotta give me a sketch, you gotta show me the intersection point, and then you gotta answer the question.
I didn't get this.
Okay, half-life. Again, you're gonna start like this. Half-life. Half-life says, start with this amount, rate is a half. I'm looking in terms of days. So I start with X, but I wanna half this every 14 days. So in your chart, you expect this. This is a good way to think this out. I start with this many grams. After 14 days, I take half of this. I take half of this. After another 14 days, I take half of this. When you put this in your y equals, your graph has to look like this. That's a good place to start.
What does it say the rate for it?
The rate, half-life.
Oh, you just.
Yeah.
Yeah, I didn't understand the first time looking for a
We
rate.
went over half-life yesterday in class.
I know, but it says like R equals.
Yeah, yesterday you gave us a rate when we were doing the class. That's-
On the half-life?
Yeah.
But
It says R equals a half.
right, I wrote that in. Articles are half.
I thought that they're supposed to be.
Half-life.
Half-life, you're decreasing.
Wouldn't it be greater than those days?
Well, yeah, X has to be greater than these days, yes.
Oh, okay.
Yes. Or X has to be greater than. Yes. Yesterday when we did this, it was the same exact problem. When we were spelling it all out, I probably just said this on the side somewhere. This is your rate, you're half-lifing. If you're doubling, your rate is 2. If you're tripling, your rate is 3. Set this equal to 1 and leave this till the very end. Still give me 3 decimal places. If they want to know how many days this will happen, it depends what other situation they're looking at. Usually you say at the end of the day. Sometimes they ask you at the start of the day, at the start of the year, at the end of the year. Sometimes they give you the year to start with, or they give you the exact date. Fill it in that way. If I said I started like January 1st, at what day will I have less than 1? If you're starting at a date, then add your full days to that. So situational graph again, you came from quadrant 2. We don't want quadrant 2, we want quadrant 1. But you came from quadrant 2.
Was that greater than or equal to or just greater than?
It should be greater than because you want to be less than 1 gram. We put the 1 gram in here. So you want to be less than that. So it's going to take you, actually, this is the more exact one. Because it's 3 decimal places. That's a 38. That's an 8. It looks like a 1, but that's an 8.
How did you get that?
We intersected with y2 of 1. You put this in your y2.
With just 1?
Yeah?
I did 0.9.
No, because it could be 0.9999999
Yeah,
and
that's
you
why
still
I-
less than 1.
Alright.
That's why this one's the more exact answer. Leave your 3 decimal places. But if you're looking at days in total, it's got to be greater than
Okay.
39 days.
So
If you do it this way, then you can put the equal sign there. but not on this one.
Hold on, wait, can I just skip it? What was the point
What was the point?
of intersection?
It was this x value, comma 1. Okay. When something doubles, what's my rate? 2. So I start with my initial rabbits, I double every month, x. So now be careful because they asked you after 1 year. They don't match. You've got years and months. So you got to change this to make sure that you match. So change this to 12 months, change your 5 years to 60 months. You can put it in your calculator and go to your table to get that answer. You can plug them in without graphing it, whichever way you like to do it. It's a lot of rabbits.
Yeah.
Rabbits.
A lot of
I
rabbits.
thought my answer was wrong at first because there's so many.
Yeah, there's so many rabbits. Well, that's the thing, that they multiply, rabbits multiply so fast. I think their gestational period is really small, short. So they multiply very quickly. If you're graphing this over 12 months, guys, if you're graphing this over 12 months and you don't know where to set your y, go look at your table. If we put this in your calculator, let's put this in your
You want
calculator.
us to put like the numbers, the values too?
Which values? Of what your window is?
No, of like how you have 20, 40, 60, 80 along the.
No, I just did that so that you would see that
You
you're
just
sketching.
draw the
You're
axis,
sketching.
right?
Yeah.
And then.
Because it said over 12 months, I think this said over 12 months to graph. So I just went to 12 months and you could just go up to whatever the 12 months is.
Okay.
When you graph this, you're certainly not, there's your situation, but you're certainly not going to see it. It goes up so fast. So when you change these and you're not sure what to make of this, go to your table. You know this one, the highest this has to be is 60 months. Because you said we were looking for the 5 years. If you just did this one where they only wanted to go up to 12 months, then just put this in at 12 if you put this into your regular calculator part
Wait,
and
that-
not your...
That one's gonna be, oh.
Well, I'm just saying, if you put this in your y1 to get this answer,
Yeah.
then x has to be go to 60.
That's what I thought we were doing, right?
Yeah, if you only went up to 12, then just go to 12.
Yeah, I just
Yeah.
ignored me.
Letter C, you put y equals 20, times 2 raised to x, but would you be able to do x over 12 too? Like, is that the same thing? Or no?
If you do x over 12, then what did you put in? Then that's x over 12. And you're going to do it by the year. You won't get the months. Well, let's try it. Let's see if
Does
it
letter
comes
C,
up.
is it asking for the year or is it for 5 months?
It's asking how many months it'll take to reach 10,000. Just let me get through this window 1 second. So here's the problem again. There's so many rabbits here. What do I set my y to? If you want to go to your table and you're only doing 12 months, you only have to scroll down to 12 months. If you want to start here, start at the 12. See where you are. What is the value at 12? Sometimes make sure you scroll over because sometimes when it does when it comes down here and does a scientific notation, scroll over it and see what the value is. So if you're only doing 12 months in your graph, make it a little higher than this. Make it, make it 100,000. Let's make your y max be 100,000. Go to your table if you need to. That's why your table's there. So now you should be able to get a grip of your curve here. And then set your y2 to whatever it is you're looking for. We were looking for, when is it 10,000? Look to see where they intersect. Okay. If you're doing your graph based on your whole 5 years, then that's different. Set your y max is going to be huge. Okay. And really, you should label these things. You're looking for how many months is it going to take? Your label should say months. If you're looking for how many rabbits you're going to get after a certain time, you should say rabbits.
I don't know, like years. No, I was saying because you have it labeled as months, right?
Yes, it's
Oh,
months.
yeah, it's months.
No, it's months.
Alright.
In less than a year, you'll have 10,000 according to this. Yeah. God bless you. Okay. Here's another one. I gave you this one. Your initial population is increasing. So we did a decreasing one. We did a 1 minus. So this one's just a 1 plus. I want to know how many years is it going to take to increase my population to a 1 million. You started at 475,000, so your Y2 says 1 million. So when you set up your graph, what's your Y max? A little bit more than 1 million because you want them to intersect, right? So do like 1 million, to do 1,200,000. You know, make it so that you can see your graph. Sometimes too, it writes in the lines on the top. So if you're too close to the top, you're not going to see the answer. Same with the bottom. It writes on the bottom sometimes, and then you won't see the answer. So give yourself enough space. Again, kind of estimate these things. If it's increasing at a good clip of almost 4% a year, it's not going to take all that much. If it's only increasing at 0.5%, it's going to take a lot longer. So it makes sense out of this. Again, this came from quadrant 2 because all your exponential curves come 2 to 1. And we don't want quadrant 2. Is this almost the same problem, right? Oh, here it gave you dates. This is almost the same problem, but this is what I was talking about yesterday with the dates. You initially start with 6,250 and you're increasing. So we set up your equation. When they ask for a situational equation, that's what they're looking for. Okay? And you're increasing, decreasing every year. Okay, now, if your population started from 1915 to 1980, this spanned 25 years. There's your X. From 1940 to 1890, 50 years. There's your X. So sometimes they give it to you a little bit differently. Sometimes they ask you, in what year will it reach, say it's increasing, in what year will it reach 100,000? If your answer has a decimal and they say, in what year, all you have to do is add that to the year, because then you'll be in that year. If it asks you at the start of the year, you're going to have to round it to the next year. Same as you did in Algebra 2. Same kind of wording. Algebra 2 loved that problem. Like when they would give you, like, it started in 1910 and in 1990, what was it? You know, or what did it reach this number in what year? Because most of the time the kids forgot to go back and do the years.
Probably point 3 of a person.
Yeah, sure. Yes. And then when you explain to them, you're like, but that's what my husband is saying.
What if there's someone pregnant?
Okay, half-life again, here's your rate, half-life. Now you're cycling this half-life every 65 days. So some of your elements have a half-life of 100 years. So you don't want to calculate it every year, you want to calculate it every 100 years. So sometimes it's years, sometimes it's days, sometimes it's months. It's decreasing and decreasing. So start with your initial grams and decrease it. It's less than 1 gram after 118 days, if you're rounding to the full days. If you want to get technical, X has to be greater than 117.478 days. So a little bit more than that, I decreased a little bit more than 1.
Wait, what is that? That's in days?
Days. Because your cycle was in days.
It just looked like it's 15.
I'm sure when you do this in chemistry, you probably get a lot more exact with this, but we're just kind of general formulas here. Do you do the same formula almost?
Chemistry's all good. I don't really remember.
Oh,
We drew boxes.
I had 3
you drew
different
boxes for your half-life?
Those were teachers. Yeah, we had 3 different subs. There's
Yeah.
people.
Oh,
My teacher also said so.
Who did you start with?
Miss Irizarry.
Oh.
And then she like had to go get neck surgery.
Oh wow.
And she just never came back.
Oh.
She like retired halfway through the year. And she
Yeah, I mean,
yeah.
I didn't even know that either.
Yeah, so we had this man, do you know Miss Colacos?
No.
You know Miss Marina?
I know her. Let's just get this finished up again. Can everybody graph this? Everybody can graph a half-life decreasing. Okay, problem situation is quadrant 1. Complete graph is 2 and 1. It came from quadrant 2. It had to start somewhere. So it came from quadrant 2, but our problem situation, our application, is in quadrant 1. So, what are we looking for? We're decreasing every 1.5 seconds. Shh. Let's get this finished.
Did you divide by 1/2 to the 6?
Yes, don't put this in and round it to divide. All your exact values have to come at the end.
But like you can divide like that?
Absolutely. You're solving for, this is your unknown. Don't forget, guys, pay attention. Your exponent belongs to this side. Do not multiply these two. Your exponent only belongs to this.
Yeah.
Yes.
I just didn't
So,
know you could divide
to get
by
this
that.
by itself, these are multiplied, just divide by that. They're just multiplied. Maybe it looks better if you write it this way. Times s. Then doesn't that look better? To divide by whatever in front of s?
Yeah.
Yeah, it's just a factor. It's just a factor.
I just didn't know because there was like a fraction to
Yeah.
it.
And P.S. Don't round until the very end. So you don't want to put this in your calculator and round it and then divide. Do every rounding at the end. Yes.
Okay, what's the point of completely graphing?
The complete graph, all your exponential curves, when we put them in just like 2 to the x, 3 to the x, or 2 to the negative x, they start in quadrant 2 and they finish in quadrant 1. Nobody's down here because we can't do negatives. Or decreasing will come this way. So this had to come from somewhere. It started here. So a complete graph shows me in quadrant 1 and 2. But in my application, I can't use quadrant 2. I never have negative signs. My application is geared to quadrant 1. Because a lot of these times, you just graph them. If you opened your calculator to all quadrants, you would see it come from quadrant 2. So are we good with this? Now be careful too. They wanted 1 minute. You can't put a 1 in there because your time cycle is seconds. That's why we went 60. Okay, so I guess we're finish this up. Do we have any questions?